All right, so we just did a BST take one, and we're going to go over the answers right now. So the first question was, how do you write a getter for a BST? Very simple question, kind of an underhand pitch. However, there is this Nodiscard attribute here that some people know, some people don't know. And so I thought I would just talk about that really fast. The Nodiscard attribute means that if you do this inside main, if you have a getter and it returns a value, there's no reason to call a getter unless you actually put that into a variable or use it or cout it or something. So this code would cause a warning because we're calling get size and not doing anything with the return value. This would be correct, right? This would be correct, and it won't warn. But if you have just a call to a Nodiscard function and you discard the return value, then it will warn. And that's usually a warning you don't want to skip over. That said, occasionally some people like putting Nodiscard a little too aggressively on things. Because there are some times where I do something and the function does something and it returns like an error code. And I don't care if there's an error code sometimes. And so sometimes I literally don't care, and that's why I'm not catching the return value. It's just an error code. If the thing failed, I'm fine with it. And it's like, no, you must pay attention to the error code. I'm like, bro, I don't care. It's like, no, you must care. And then you're like, okay, fine, I'll capture the error code. Like this. And it's like, you're not doing anything with that variable. You have an unused variable. You're like, oh my lord, And it's like, sometimes like I just want to like just not deal with something because it literally doesn't matter to the correctness of my code. And so like the main culprit here is the system function call, which in C++ allows you to do something like, remove all of your files. No, you don't want to do that one. If you want to do like figlet, hi, something like that. This actually runs a Unix command inside of your program. It actually runs the Unix program immediately, and it's going to do this right in the middle of your screen. Cool. Or figlet hi, pipe through lolcat like this. And then it's going to print it in colors. Yay. Pretty cool stuff. But you know what? If that thing fails, who cares? I don't care. Do you care? I don't care. And so like it'll warn because system is, in my opinion, incorrectly flagged as Nodiscard because it does something. With get size, the only reason of get size is to return a value. And so it doesn't do anything else. So if you're dropping that return value, if you're discarding that return value, you're wrong, very probably. With system though, it's doing something and then just like returning an error code to you. And like literally, if I'm not catching it, that's because I don't care. If it succeeds, if it fails, I don't care. And it gets mad at me if I don't. So that I have a little bit of issue with. Them flagging that as Nodiscard. Okay, next up, we're going to talk about how to... Yeah, it's a really neat attribute, and there's all sorts of attributes in C++, which you will learn. There's like likely and things like this. You'll learn in 45. It's not super important for right now. Okay, so let's write our insert function. And so this insert function, you assume you have a node class and a tree class. So all you got to do is write the insert function. Okay, so it's going to return true or false. That means the return type has to be bool. And some of you guys had a void for get size, which is not good. Some of you guys forgot the const. That means that this does not mutate the state of the object that it's called on. You want to have const there. And yeah, okay. So bool insert, and we're going to be taking a const string by reference s. And we are going to be saying if root is null, or I could abbreviate this as if not root, of course. So if root is null, then root is equal to new node, pass in s, size plus plus, and we return true because it was successful. If there is a root, then we're going to say node pointer current equals root. And let's scroll this up a little bit. And so we're going to start off with a pointer at root, and then we're going to say while true. Now we're going to iterate through the tree. This is a standard tree traversal algorithm you should probably get used to. So you start off at the root, and then we do this. If we have a match on the key, if we have a duplicate value, in other words, cur points to get data, return false. So this was part of the assignment. Write an insert function that will return false if it's a duplicate key. Returns true if it was successfully inserted. Return false if it was discarded without inserting. In other words, it's a duplicate. And this brings us to like a topic that of like when will you use data structures? You know, because like you're like, well, the standard library exists and the standard library does everything, does it? Well, no, not exactly. I mean, it kind of does, but it really doesn't. You will still need to be able to write data structures. For example, something like this, where you need to know, like, you do an insert, does it fail? You know, you could use the standard library and like do a search and see if it's in there and return false. You know, like you could still use the standard library, but you're still writing your own data structure that has certain behavior that is required for your application. Or maybe you go to work for a company and they're like, if there's ever a duplicate, I want you to throw something. You're like, okay, what do you want me to throw? And like, I want you to throw the number 42. And you're like, okay, that's dumb, but sure, whatever, you're the boss. And so you're going to be given specifications you need to code to. And so sometimes you will have to make your own data structures. A lot of times you can leverage the existing stuff. You can leverage the standard library. You don't have to remake a linked list or a binary search tree a good chunk of the time. But sometimes you do. And so that's why, you know, this class exists. It's not only to teach you about big O stuff, but also so that you can actually make your own class if you had to. Okay, so if we got a duplicate, we're going to return false. If S is less than current points to get data, we go into the left. So if that spot is available, if we're trying to go left in the tree and there's a blank there, we can check that for if cur points to get left is null pointer. Then we got an opening, and we're going to say cur points to set left new node S. Like that. Size plus plus. Return true. And otherwise, if that spot's not available, then we move our pointer down to the left and we repeat. So cur equals cur points to get left. And then we just copy and paste this for the right. Okay. So that is your competency exam. If you didn't do great, don't worry about it. There's going to be another one on Friday. So we'll be doing another standard library function of some sort. This was really a test to see if you guys could memorize a standard algorithm, really. And this is you know, not this is like the standard, you know, way of going through a tree. You know, you can do it recursively also, but having like a while loop where you go left, you go right, you go left, and you do something like that's, if you could have this memorized for today, you know, you basically would have passed the test. So I'm almost done grading them, but there's 5 or 6 left that I still need to grade. Okay, so let me stop this recording here, and then we will learn about the array representation of binary trees next.